All right, so we're going to go ahead and continue here with number 7. This is our day 2 of 3.10 for AP Precal. So in this particular one, if you notice I have secant, I forgot to fix that. This right here actually should be cubed. So here, if you notice, I've got secant cubed, secant squared, secant, and then I have a whole number. So I know I at least don't have a GCF, so instead I'm just going to go ahead and pull everything to the left and go ahead and factor. So I'm going to have 3 secant cubed x plus 3 secant squared x minus 4 secant x minus 4 is equal to 0. It looks uglier than it actually is. I have 4 terms here, and it makes it really nice and easy to go ahead and take this and just go ahead and solve by grouping. So grouping just means I'm just going to take those first 2 terms that I have right there, pull out a GCF, and write what's left. So if I have 3 secant cubed and 3 secant squared, they clearly share a 3 secant squared. So I'm going to go ahead and pull that out. So I have 3 secant squared x that I'm pulling out. Now, if I pull out 3 secant squared x, what I'm going to have left here is, I'm going to go ahead and write this all out. 3 secant cubed divided by 3 secant squared. The 3's are going to cancel out, and I'm going to be left with just one of these up top. So 3 minus 2 gets me 1. So this is going to be secant x plus, and then what I'm going to have here, I've got 3 secant squared divided by 3 secant squared. Well, that completely cancels out. It doesn't go away, though. I still have something there. It's 1, okay? Now I'm going to go ahead and come over here to this side. And if I look at both of these, they share a -4. And that's going to be it. So I'm going to write -4. Oops, thought I changed my pen color. -4 here. And I'm just going to divide this by 4, and I'm going to divide this by 4, and actually it's -4. Okay, so once I do that, that's going to go ahead and reduce down. The 4's, -4 is going to go away, and I'm going to be left with secant x. And then I have -4 divided by -4, and that gets me +1. And then this is set equal to 0. Now, when you solve by grouping, when you get it set up like this, what you have here should always be the same. So what's inside the parentheses, what's remaining after you pulled out your GCF from both set of pairs is what you would have in one of your parentheses. So I'm going to have 3 secant squared x minus 4. I'm getting, why did I write 14? -4. I'm getting that from here and here. And then that's going to be multiplied by this value here that's inside the parentheses, which is secant x plus 1. And so I could go ahead, I could distribute this all out and multiply it out and see what I get. And it is going to bring me right back to where I started with the 3 secant cubed x plus 3 secant squared x minus 4 secant x minus 4. Okay, and then this is all set equal to 0. Now, just like before, I'm going to take both of these. I'm going to set them up as separate equations. And so now I have 3 secant squared x minus 4 is equal to 0. And then I have secant x plus 1 is equal to 0. And then I'm just going to go ahead and solve those. So in this left case here, I'm going to go ahead and add 4 to both sides. And that gets me 3 secant squared x equals 4. I'm going to divide by 3 to both sides. And so that gets me secant squared x equals 4 over 3. And then now I've got to go ahead and get rid of the squared. So I'm going to square root everything. And so that's going to get me secant x is equal to. Now I've got the square root of 4 thirds. That's no different than the square root of 4 divided by the square root of 3. That gets me plus or minus 2 over square root 3. So what I have right here, what I'm looking for when I do my inverse, is I want to know when does x equal, for my cosine, square root 3 over 2, both positive and negative. Okay? And then I'm going to do this one over here. So I've got secant x plus 1. So I'm just going to subtract 1 from both sides. And so that gets me secant x equals negative 1. And so when I do this one, I'm looking for the inverse when secant is equal to negative 1. Or also, the reciprocal of negative 1 is negative 1. So when does cosine equal negative 1? So my final and complete answer, if I write this out, I have x equals, so cosine equals negative 1 at pi, and only at pi. And then cosine equals square root 3 over 2 at pi over 6 and 11 pi over 6, and it equals negative square root 3 over 2 at 5 pi over 6 and 7 pi over 6. So my answers are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And there we go. I'm done here. So that would be my final solution for this one. Okay. All right. Let's look and see what we got here on this next one. Number 8. So right here, I've got cosine x sine x equals 3 cosine x. So just like all the other ones, I'm going to go ahead and get this set equal to 0. So I'm going to subtract 3 cosine x to the left. And so that's going to leave me with cosine x sine x minus 3 cosine x is equal to 0. Okay? All right, so if I look at this one, what do they share now? I can see this side has a cosine and this side has a cosine. So I'm going to go ahead and just pull that one on out. So once I do that, I'm left with sine x here. And then over here, I'm left with minus 3. I still have my cosine x on the outside, okay? I definitely encourage you guys, anytime you pull out a GCF and you're setting these things up, go ahead and just double check, redistribute what you have right here and make sure that it does equal what you started with right here. If it doesn't, you can catch an easy mistake right there that would cause you to have the entire problem wrong. So now what I'm going to go ahead and do is set that up and set it equal to 0. So I have the outside term and that inside term. Don't forget that outside term, the GCF, also gets set equal to 0. Anytime it's factored out, no matter what it is, you're setting it equal to 0. So now here I have sine x minus 3 equals 0 and cosine x equals 0 on the outside there. So when I go ahead and solve these, I'm looking for when does cosine equal 0. And then over here, I'm going to go ahead and add 3 to both sides. And so then here, I've got sine x equals 3. And so then I'm going to go, okay, so I've got x equals sine inverse of 3. So then I'm going to go ahead and figure out what my final answer would be. So I've got x equals, well here, where does cosine equal 0? Cosine equals 0 at pi over 2 and at 3 pi over 2. When does sine equal 3? Well, it doesn't, ever. I have a range on sine as -1 to 1. So that 3, it's outside of my range. So that's my final answer here, is x. I have no solutions from this part, and that's okay. All right, let's look here. All right, so in this one right here, I've got cosine of the 4th plus cosine squared minus 2 equals 0. This one looks a little bit different. A lot of times we're just going to look at this and we're going to kind of panic a little bit because it's not squared like we're used to. Instead, it's to the 4th. Well, it's no different than how I would do it. In fact, in this case, what you're looking for here is that whatever I do put in my first term, So in this case, it would be cosine squared x. I have to be able to multiply it by whatever I put in my second term to equal what I've got here. And so the only way that I can do that is go cosine squared times cosine squared. And that works out for what I need. And then now this is no different than just traditional factoring, where all I have to do is figure out what multiplies to get -2 and adds to get +1. And so that would be +2 and -1. And that's set equal to 0. So now I'm going to take both of these and I'm going to set them up as their own equations. So I've got cosine squared x plus 2 is equal to 0. And cosine squared x minus 1 equals 0. And then I'm going to I'm going to subtract 2 from both sides and add 1 from both sides. And so that gets me cosine squared x is equal to -2. And over here I get cosine squared x is equal to 1. Now, in order to solve for x, just like a lot of these other problems, I have to go ahead and square root both sides. And so when I do that, I get cosine x is equal to plus or minus the square root of -2. And right here, I'm going to go ahead and do that. And I get cosine x is equal to plus or minus the square root of 1, which is 1. And then now I've got to go ahead and do my inverse. Well, problem that I'm going to reach right here is this negative that I have right here underneath my square root. Anytime I have a negative underneath my square root, I get an imaginary number. And so from here, I'm going to get no solution, okay? However, I'm going to check over here and see what I get. Well, I'm looking in this case, where does cosine equal plus or minus 1? Well, cosine equals 1 at 0, and it equals -1 at pi. It also equals 1 at 2 pi, but if you recall, if I go up here to the top, my interval is only between 0 and 2 pi. That parenthesis indicates that it's not including 2 pi. So it's 0 to 2 pi, not including 2 pi, but it includes 0. So that's what I've got for this answer here. I am not going to include 2 pi, and that's it. All right, this last little bit here, we're going to talk about solving equations that I wouldn't normally be able to solve, and I'm going to use my calculator in order to do so. Okay, so in this case, I'm given 4 cosine x equals -4. I can solve that by hand. That's no problem. I can easily do that. It'd just be when does cosine equal -1? And that's going to be at pi. But instead, I'm going to do this using the calculator, and it's going to make my life a little bit easier. So what you're going to do in order to do that is you're going to take the left side of your equation, set it up in your y equals portion of your calculator, and then you're going to take the right side of your equation and set it up in y equals as a separate equation. So just like this that I've got right here, okay? So I'm going to pull out my calculator, and I have to make sure that I have it in radians mode. And then I'm going to go into y equals, and you can see here I've entered both of those equations in as their separate equations. Now I can go ahead and graph it, and you can see right here where these lines are going to overlap. That's exactly where their solutions are. I'm going to kind of help myself figure out where those solutions are and kind of narrow it down, and so I'm going to change the window on my calculator to match what I need it to match. So I have all of my answers need to be between 0 and 2 pi. So I don't care about -10. I'm going to set my minimum to 0, and I'm going to set my maximum to 2 pi. As far as y goes, I can change that if I want to. I mean, it's not really going to help or hurt me here. So now that I've just changed my window here, I've got this. So I can see right here, I'm going to have one solution between 0 and 2 pi. Now, in order to figure out what it is, I'm going to hit second trace, and I'm going to go down to intersect. So you can see right here now that it says first curve down here on the bottom. And then up here, it gives the equation of 4 cosine x. It's also blue, okay? So that's telling me the blue line is that. And it's wanting me to confirm, is this the curve that you're wanting to look at? That's what it's asking. Yes, it is. So I'm going to hit enter. Second curve. Now it gives me the equation of the second line, and it's now red. It's not blue anymore. It matches that equation. Is that the line that I want to look at? Yep. Now, guess. I need to scroll along until I'm kind of close to where I'm at for my intersection, and I'm going to go ahead and kind of get close there and hit enter, and then it's going to give me the intersection point. So this is 3.1415921. Huh. That sounds vaguely familiar. Oh, right. That's pi. So that's exactly what I've got right here. So that's how you can find your solution using the calculator. So this one, I'm just going to get x equals, and it's 3.14. Okay. Oh, so that's what I got. Oh, 3.14. Sorry, I forgot. I need 3 decimals. 3.1415. So it's 3.142. Okay. So number 11. I'm going to do the same exact process. I'm going to set this up in the left side and this up in the right side of my equations here. So let's go ahead and set those up. So if I put those in the calculator, this is what I end up getting. So you can see right here I entered in y equals 5 and y equals 6 sine 2x. And I get this as my graph. Now, you might be kind of saying to yourself, well, this is from how I set it up last time. And the way I set it up last time was between 0 and 2 pi. If I look at this question is asking me to find between negative pi and pi. So that means I need to go back in here and change my window because I'm not getting any of those negative values. And in fact, I'm getting answers over here that I don't need because those are between pi and 2 pi. So I'm going to go back in here and change my window, and I'm going to change that to negative pi to pi. Not that one. So there we go. Now if I graph it, now I get this. So I can see here I've got 1, 2, 3, 4 solutions. And I mean, that makes sense because here I've got a 2x. And so we should know that that means that that's going to go ahead and get me multiple angles. And so traditionally what I would have had here would be sine inverse equals 5 over 6. And we don't know where 5 over 6 is on our unit circle. It's on there somewhere because it's between 0 or between -1 and 1, but I have no idea where. It's not some exact value that I have memorized. So now what I can do is I can go ahead and do my second trace. And I'm going to scroll down to intersect. And so now I'm going to look. So again, it's asking me first curve. So it wants me to pick the blue line. Sure enough, that's what I got. Second curve, red one. Is that the one I got? Yep, that's that one. And now it wants me to guess. So now I'm going to scroll over here and kind of get close to that one. The reason I'm doing this is because otherwise it doesn't know which intersection to give me. I'm looking at 4 intersections on this particular screen. So I'm going to pick this one. So this way it gives me the intersection of -2.649. So I've got here, my x is going to be equal to -2.469. Is that what it was? Yeah. No, -2.649. Sorry. So we got 2.649. Okay, that's one of my solutions. I need to list all 4, just like I did in all of the previous times of having to find them. Now, in order to go ahead and get that, I need to find my next intersection. So I'm going to go through the process again. Second, trace, intersect. First curve. Okay, I'm going to pick the blue one. Second curve, I'm picking the red one. And then I'm scrolling close to my answer here. And it gives me my answer as -2.063. So I'm going to go ahead and write that. -2.063. All right, and then let's go ahead and try one more time. That's going to go ahead. First curve, blue one. Second curve, red one. Yes. So now I'm going to go ahead and get close to this intersection over here. Hit enter. And I get 0.4925, so 0.493. And I have one last one to do. Same process. Second trace, number 5 for intersect. Going to go ahead and set yes for first curve, yes for second curve, and then I'm going to scroll close over there, and it moves me to 1.078. There we go. So those are all of my answers for that one. So that's how you can use your calculator to help you out. All right, that's going to complete day 2.